Hello everyone, welcome to ToupTek Astro channel. Today we will show you the full tutorial on how to use StellaVita to complete a shooting session. Let's begin. Step 1. Wi-Fi connection. Connect your device to StellaVita's Wi-Fi. Now the pad is connected to the StellaVita's Wi-Fi successfully. In MISC, you can check the version information of the StellaVita app. Then now we can see the main interface of the app. If you have this prompt, click Continue. Step 2. Equipment connection. Next, we need to connect our equipment to StellaVita. Here I use iOptron HAE43C mount, so I need to select it from the list and then connect. Secondly, choose ATR585M from the main camera list and connect. Thirdly, choose GPM4622C as the guide camera and connect. Then, choose the filter wheel and connect. Here you can adjust the name of different slots. Then, choose the ToupTek AFF and the electric focuser. Step 3. Manual Coarse focusing. First, let's adjust some settings. Choose the video mode. Adjust the focal length according to your telescope. As we are using the OAG, so the focal length of the guiding camera remains to be 280 mm. Now let's back to the main camera interface in video mode. We can see some start points here. After adjusting the settings of a telescope and guide camera, we can start the process of autofocus. Open the setting of autofocus. These two little up and down arrows can control the movement of the electric focuser. We can open the reverse function of electric focuser to make it move to its shortest position. And then set current position as 0. Now we can turn reverse off. And we can adjust the arrows to focus. At this stage, the stars looks quite sharp. The histogram seems fine. Now we can change the main camera to single mode. Try to take a picture and check if the picture can be played soft. Okay, the image is overexposed, so we can turn down the gain and exposure. And try again. Okay, now we can use plate solving results to adjust the focal length. Click Apply and Sync. Step 4. Polar Alignment. Go to Mount Interface and click Polar Alignment. Confirm the time, longitude, and latitude here. And then click the Take Image button to start the polar alignment. Now we can check the polar alignment result. Okay, I need to move the mount downwards a little bit and refresh. Okay, we have reached a good result of polar alignment. To ensure the polar alignment accuracy, we can perform a second one. Control the mount to move to the previous position and take another image to check the accuracy. Now we need to adjust the mount upwards a little bit. Step 5. Move to Target. Choose the single mode in Main Camera Interface, go to Setting and choose Mount. Click on Home to return to Home position. Next, we need to select the target for our shooting. The yellow frame indicates the mount's current position, and the blue frame is the target that we want to choose. Let's select M53 as our target. Choose Center Simulation, and then choose Go to and Center. In this process, we can adjust a higher gain in Go to and Auto Center, and set a smaller exposure. We can use values of the main camera. Then choose Go to and Center. Turn meridian flip on, and the time can be set longer. Now the telescope is pointed at the target, M53. In the middle of the screen, you can see there is a cluster. Step 6. Autofocusing. Now we can start focusing. Go to Setting and turn on the tracking of the mount. Next, we need to set appropriate autofocus step and overshoot step for electric focuser. And these values can be tested on your own. For my setup, I will use smaller values to test, as it is also the first time for me to use this setup, so you can see my process for adjustment. Here it says autofocus failed. As this curve doesn't match the fitted one very well, So we can set a new value for electric focuser and try again. As you can see, from 11 to 5, there are only 3 steps. It shows a big shift in values, so we can set the step to a smaller value. Let's try with 30 and take a new image. A minor spike can be observed in this image. This is caused by computational errors in the HFR algorithm when processing extremely fine star points during imaging. We can adjust the gain lower and try again. As you can see, these star points are still very fine. Let's try a bigger value for step. Now we have reached a quite good result. Then we can move to filter wheel setting and set gain and exposure for different slots. The L channel's gain can be set to 100, which is as same as we tested before. And it is also the same for R, G, and B channel. For H alpha, we need to choose a higher gain. Let's set it as 1000. If you don't know which value you should set, you could do some tests and find a proper value for it. For example, set the current position to 5 and try to take an image. You can see the stars are not focused. Then, let's adjust the gain of H alpha channel to 250 and set exposure to 1. Try autofocus again. Now we have a perfect curve of autofocus. So we can use these values of filter wheel setting. The values of sulfur 2 and oxygen 3 are as same as H alpha. Please note that for autofocus, the exposure time should be no shorter than 1 second. If it is shorter than 1 second, star points may be severely distorted by high-frequency atmospheric turbulence. Excessively long exposures can amplify tracking errors across the entire imaging. Step 7. Guiding settings. Next, we can start to adjust the guide camera. Let's turn the gain to a higher value. You may see some blur, even no star points at the beginning, but it's fine. We can try a longer exposure time and a higher gain value. And check the histogram value. When we see the stars on the screen, we can set the exposure time shorter. to obtain a higher frame rate. Okay, now we get some sharper stars. And then set a normal exposure time to improve the signal-to-noise ratio. Long pressing on the stars, it now can be selected. Next, let's check the guiding setting. The focal length is 280mm. Gain is also fine. Then we need to make sure that the guide rate of the mount is appropriate. For most of the mounts, the guide rate can be set to 0.5. Move back to guiding camera and calibrate it. Please note that long pressing on this button can delete the data of previous guiding calibration. In the guiding calibration process, the guide camera drives stars in a single direction for a fixed displacement of 25 pixels. Upon reaching 25 pixel displacement, the system reverses direction to return to its origin. The movement pattern determines the required number of steps for calibration in different directions. You may notice some slight flickering in the image, but it is fine. It is caused by minor interference during the video stream transmission. Since StellaVita pre-authorized fast data transfer to provide users with a smoother experience, the image may occasionally appear incomplete, but it has no significant impact. Here is the guiding data. Double-click to clear previous data. The guiding is performing well. Step 8. Capturing plan settings. Now let's move back to the main camera interface and set up a capture plan. We will choose M53 as our target and add it to our capture plan. First, turn on Slew to Target, Center Target, Start Guiding, Stop Guiding upon finish, Autofocus on filter change, and Autofocus on beginning. Stop guiding during autofocus is specially set for OAG users. When using OAG, it is inevitable to be out of focus at some point, so we need to turn it on. Next, move to Task Management. Let's create a new light task. Set gain to 100. For exposure time, we can find a proper value through tests. For example, we can go to the main camera interface and choose the conversion gain mode. Here I am using HDR mode for ATR 585M. Let's set gain to 100. For H-alpha channel, I will set the exposure longer, for example to 300 seconds. But for L channel, the exposure time can be shorter. Then start shooting. Check if guiding is performing. Okay, there is no problem with guiding. Now the first image is captured. Let's check its histogram. It means using H-alpha filter and setting exposure time to 300 seconds is totally fine. So we can go back to task management, choose to use H-alpha filter and set exposure time to 300 seconds. Set interval time to 1. This means that capture of the next frame will not start until 1 second after the previous frame has been captured. Total means how many shots are performed in total for this task. Then add a new task and choose other filters. Check the task management again. And make sure all these functions are turned on. Then start capture. This image is quite good, without any significant problems. The star points are sharp, and the guiding is working. RA has a bigger error in this case, so we can go to Setting and set RA aggression higher. It is better now. Let's set the value higher again, and then we can wait and see the final results.